Hello. In this video, we will break down three important AI system design patterns: RAG, AI RAG, and Agentic RAG. They sound similar, but they behave very differently in production. By the end of this, you will clearly know how each one works, where each one fails, and when you should use which approach. So, large language models are powerful, but they have a core limitation. They don't know your private data and they can hallucinate. RAG, Retrieval Augmented Generation, which was created to fix this. So instead of relying only on memory, we retrieve real data at query time and give it to the model as context. Here, it shows classic RAG. The flow is simple. A user sends a query. That query is converted into an embedding which captures semantic meaning. We then search a vector database to retrieve the most relevant chunks. Then, those chunks are stuffed into the prompt along with the question. The LLM reads everything once and produces an answer. So there is one retrieval, one generation, and no iteration. That's why this is called fetch and stuff. Now, this AI RAG improves on this by adding self reflection. So instead of stopping after one answer, the model evaluates its own response. If something is missing, the model generates a new internal query. That query is embedded again and sent back to the vector database. So this creates a refinement loop where each loop helps the model to improve recall, retrieve missing context, and refine the final answer. Most importantly, this loop is bounded. So there is a fixed number of iterations, so latency and cost stay predictable. AI RAG is slower than RAG, but it is significantly more accurate. And it works well when the information is fragmented, answers require multiple sources, and correctness matters. So, what makes Agentic RAG different? Agentic RAG systems include planning, tool calling, memory, and conditional logic. This enables autonomous research, enterprise copilots, complex workflows, and decision making systems. The trade off is higher complexity and cost, but much higher capability. Now, the comparison. So, here's a simple comparison for RAG, which is fast but shallow, AI RAG, which is thoughtful but bounded, and Agentic RAG is adaptive and powerful. So, choosing the right one depends on the problem, not hype. Now, use RAG for simple document search, use AI RAG for complex question answering, and Agentic RAG when the system must think, plan, and act. So, understanding these patterns is critical for AI system design interviews and real world production systems. Now, let's now zoom inside the RAG pipeline and look at the actual data flow step by step. Everything starts with the user prompt. That prompt is first converted into a JSON request. So the system can pass it through different services in a structured way. Next, the text part of the prompt is sent to the vector embedding model. This model converts the text into a numerical vector that represents semantic meaning. Because embedding generation is compute heavy, so this step is usually GPU accelerated, especially at scale. Once the embedding is created, it is sent to a vector database. Here we have used Milvus, which is the vector database here. Yeah. Inside this database, the request is routed to a specific shard, which helps with horizontal scaling and faster similarity search. After that, a metadata filter is applied. This filter narrows down results based on things like document type, date, sorry, document type, date, tenant, or access control. So, this step is critical in production systems because it prevents irrelevant or unauthorized data from being retrieved. The filtered results are then passed to the LLM pipeline. Before the model can use them, the text is processed by Llama 3 tokenizer. Tokenization breaks text into tokens the model understands. So finally, these tokens are combined with the original query to form a contextual embedding, which the LLM use to generate the response. So the key takeaway from here is RAG is not just retrieval, it is a carefully orchestrated pipeline of embeddings, search, filtering, and context construction. Now, let's compare it RAG, AI RAG, and Agentic RAG using a racing analogy. And it's actually a very accurate mental model. So, this is a classic RAG. Our classic RAG is a direct sprint. The query goes straight to retrieval. The retrieved context is sent directly to the model, and the model produces a response. It is fast, it finishes quickly, but the downside is clear: limited context, single shot retrieval, and no chance to recover if something is missing. Now, AI RAG, it introduces a smart bit shop. Before finishing the race, the system pauses to analyze the query. If there is a cache miss or if the context feels incomplete, the system fetches more information. This creates an augmented context. The model then finishes the race with more data, better recall, and an enriched final answer. It is iterative, not single shot. Finally, Agentic RAG, which is a strategic overtake. So instead of following a fixed path, the system creates a multi step plan. The agent can fork into a parallel path. One path search for information, another refines the query, another synthesizes results. So all of this produces a much richer context. The finish here is superior, not because it is faster, but because it is smarter. And unlike RAG or AI RAG, this workflow is autonomous. The system decides what to do next, when to stop, and how to combine results. That's the real evolution from fast answers to intelligent systems. Thank you for watching. Please like, comment, and subscribe to my channel AI on Mind AI and click on the bell icon.